Hello Algebra 2. Tonight's video has 3 learning targets, and they are: I can verify a formula, I can understand how to factor any problem, and 3, I can apply my knowledge to factoring to a real life situation. And our first topic is our first learning target, and the question it leads off with is, what does it mean to verify? I want you to go ahead and pause the video and think about that word and what it means to you. And to me, the word verify means to prove something and check if something is true. And when I went to look it up as I created this video tonight, that's actually the definition, the first 2 definitions that come up when you use Encarta Dictionary. So I thought that was interesting. And then where I've seen this word verify the most is I always think about the court or law when it comes to that word verify. But the whole point of the word verify and understanding that word means that you have to prove. So thinking back more to geometry where you've done proofs, that you have to prove that something is true. So our first one we need to verify is, or show, another way for verify is also show that a cubed minus b cubed equals our formula for this is for our difference of cubes. So I'm going to add the word show as well, because some people that will help people understand if they think of the word show. And the way that we show with a formula, especially with one equal to the other, is to make one side equal to the other through either multiplication or combining like terms. And in this case, we are going to multiply our right side here to show that it equals our left side. Okay, so let's go ahead and multiply this right side, and I'm going to show this using the box method. Anytime I have a binomial times a trinomial, remember a binomial is 2 items and a trinomial is 3 items. I now prefer to use the box method just to make sure I collect all my like terms and don't miss all my multiplication. So we are going to verify through multiplication that this whole item here is equal to a cubed minus b cubed. So I'm going to set up a box that has a 2 by a 3 here. And so we have a minus b for this, our binomial. So that's why it's a 2 by a 3 with a trinomial. And then a squared, ab, and b squared. So go ahead and pause the video and multiply through and see what you can bring it back. Alright, so you should get in this box a times a squared would be a cubed, and then negative b times a squared would be negative a squared b, and then a times ab would be a squared b, and then negative b times ab would be negative ab squared. Then a times b squared is ab squared. And last, we have b squared times negative b, which would be negative b cubed. Now notice that we have negative a squared b and an a squared b. So we have a positive and negative, so that would add to 0. So those would cancel. And we also have another negative ab squared plus a positive ab squared. So if we add those two together, that's 0. And we can see our final answer. The only thing left is a cubed minus b cubed. So we have verified that this formula is correct through multiplication. You can also show this using the distributive property and combining like terms. Go ahead and pause the video and try to verify problem number 1 and problem number 2, and then bring it back. So I have the work shown for number 1 in purple, and I just used FOIL to multiply my two binomials. And you can see that the inner and the outer are the same except for their opposite signs. So they would cancel. And then number 2, to verify the sum of cubes formula, we can show that our a plus b times our a squared minus ab plus b squared is equal to a cubed plus b cubed. And in this time I showed the distributive property. So if you prefer that method, you distribute the a and multiply a by all 3. So that's my first 3 terms. And then the b to all 3. That's my last 3 terms. And then combine like terms. So we verified both number 1 and 2. Remember, if you have questions, you should be, on anything I'm saying, go ahead and write them in the summary on the back of your notes. Let's go ahead and look at the real life application here below our verifications problems. And if we think about this problem, we have a area rug that's square. So let's put a square here. So if we think of a square rug, and the area, remember, is the inside of the rug. That's what this question is telling us, that the area is 25x squared minus 10x plus 1. And it wants to know the dimensions of the rug in terms of x. So the first thing we have to remember, and prior knowledge, is what the area formula is. So with any rectangle, it's length times width. But when it comes to the square, remember, a square would have all the same sides, so our length will be the same. So when you are factoring out a square rug, we should get the same dimensions for our square. So again, we're finding this area, and we want to know what the length times the width is, and our length and should equal our width because it's a square. So our area again would be 25x squared minus 10x plus 1 equals my length times my width, which again will be the same thing. Now if you think about what this is, we have a quadratic, and we know we have two things that are multiplied to that quadratic that they are going to be the same since we have a square. So anytime we have to find what multiplies to something, we're going to be using our factoring. So right away I'm going to start to factor to find what the dimensions. Remember, the dimensions are the length times the width. If they were talking about a dimension in a piece of wood, it could have, the length and width and the thickness of it. But a lot of times when we think about a 2x4, they're talking just about the length times the width. But sometimes dimensions can also include the depth. Here for area, there's only two sides. We're We're just looking at the top of the rug. What are the dimensions? So I'm going to go ahead and try to factor that problem and come up with the dimensions. Go ahead and pause the video and try that. So when you factor 25x squared minus 10x plus 1, you should get 5x minus 1 times 5x minus 1. And to answer the word problem, you'll say that it's 5x minus 1 by 5x minus 1. So give them the length times the width. You could also write it out that the sides, each side is equal to 5x minus 1. All right, one more part here to our notes tonight. Our last learning target to talk about is how do I know which factor method to use? And we have some steps here that we have proven at our school have really helped students be able to factor any factor problem. And the first step, always, 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 I've been starring it on all these slides, is to factor out, that's right, that greatest common factor, the GCF. Our step number 2 is to determine the number of terms and then use the correct method. Our step number 3 is to make sure it's completely factored. You have to look at it, keep going until everything is prime, and check your answer by multiplying. So our step 1 is we're going to factor out the greatest common factor. Our step 2 is we're going to look at the number of terms. So here's another visual for you. Here's a flow chart in the same steps. So our 2 terms, remember, would be a binomial. And think of the word by, the root word of part of by, where we have a bicycle to help you remember the 2 terms. And then for try, the root part of try for trinomial to remember 3 terms. And then 4 terms and more we call polynomials. So you don't have to remember, but poly would be many. So once we've determined how many terms are left after we've factored out the greatest common factor, then we think about all the things we've learned so far. And remember, all our binomials, our special cases, we're looking for patterns if there's only 2 things left. And the patterns could be with perfect squares or perfect cubes. When it comes to the perfect squares, it must be a subtraction. And then if they're both perfect cubes, it can be a sum or a difference. When it comes to trinomials, we can use our logic method to factor using reverse FOIL, or we could use slide and divide. And then when there's 4 terms, we're going to use factor by grouping. You may have learned this in Algebra 1. We're going to learn, if you haven't learned it yet, that's going to be the next video. So we'll learn how to factor by grouping next. Now let's try to look at a problem. Our first example is 7x cubed minus 56. And we want to do step 1 here first. Factor out that greatest common factor. When I'm looking at my 2 numbers, I immediately think about 7 as the greatest common factor. Go ahead and factor that out and pause the video and factor the 7 out. Check with me in a minute. So when you factored out 7, you should have in your parentheses x cubed minus 8. Now notice that we have 2 terms here. So with 2 terms left, we're looking for cubes or squares. And we do have 2 cubes. So we're going to keep going. We're not done. We're going to keep going and factor out our cubes. So go ahead and pause again and do that. Okay, you should have gotten this when you factored x cubed minus 8. Now go ahead and try 2 and 3 on your own and bring them back. Okay, when you uncovered the greatest common factor in 2, you should have found a difference of squares, And then in 3, the greatest common factor